Okay, so as we look at what's up on the board, okay, the upper left-hand corner, okay, if you had to name them and add together their atomic masses, how many of you would have no problem doing that? Those three, or those top two. So is there any, so no hands are going up that, just one. Who does not, let me restate that. Who would have a problem? That was the original question. Who would have a problem doing those? One, two, three. Who would have a problem doing, am I not enunciating that enough? Or what? We're not communicating. Tell me, why are we not communicating? What is unclear? So we we don't, this is for your benefit, and how about we just, what you're telling me is just let the cards fall where they may. Some of you have really backed yourselves into corners, and administration has addressed that, and even after addressing it, we still just decide, well, that's just how we're going to approach this. So what you're telling me is just let the cards fall where they may. I just said that. Is that what we want? Probably not. So do you want me to go over this? Yes, no, or we could not care less. Go over it. Okay. And we can do that. Right? So we should have somewhat of a general idea, especially by tomorrow. So when next week rolls around, if your hand is up, that means you are not, N-O-T. If your hand is up, you are not taking that final. Okay? So, does anyone think they are not taking it? Hands up. One. Okay? So, that puts us, you can tell me tomorrow. Okay. So, going back to an earlier question, maybe this row should select someone to come up and explain to the rest of the class. So nobody wants to do it, huh? Don't want to or don't know how? All right. So let me ask you this. How many of you feel comfortable going into next week? Okay, all right. So as we go over this is for your benefit. Would you agree, or would you say, the old man's wrong, we're just going to do what we want to do? Okay. All right, fair enough. So then, what does CO stand for? Okay. So where is cobalt located on the periodic table? What block? So what can be a characteristic of D block elements, unlike zinc and silver? Those are exceptions, because when you look at the element box for zinc and silver, what do you see in there for charges? A +1 for silver and a +2 for zinc. Is that true with cobalt? No, because what's true about cobalt? It has multiple charges like a lot of D block elements do, and some in the P block as well. So We had always said go by which ion to determine what the charge is. The negative ion. Okay, so what does Cl stand for? Okay, so what's the charge of a chloride ion? Okay, so how many total negative charges do we have? Okay, so if all of these is -3, well then this has to be a charge of what to add up to 0? +3. So how do we denote cobalt as a +3 charge? Okay. All right. Then adding together the atomic masses. Okay. One chloride ion has a mass of what? Okay. So how many chloride ions do you have? Okay. Now you can just take that times 3, or you can do this. Okay, and then we need to account for your cobalt. Okay, so then, of course, what you would do is add all of them together. You can do that with pencil and paper, or you can take 35.45 times 3, like we said, and then add together your 58.93. Get 165.28. The atomic mass. Okay? For those of you who go on to take general chemistry, it would be called the molar mass. We don't need to be calling it that right now because it's just going to confuse you, I'm afraid. Okay? If there's one of the things that kind of a little perplexed by what we've been discussing. We say that we don't understand, but yet, and maybe it's possible. You just sit here and just soak it all up, and just hopefully that when we need to recall that information, it's there. So, does anyone else find that perplexing? No? Okay. Since some of us aren't taking it, I bet you're perplexed. Well, I believe you, because you've already answered all these. You know what you're doing. Yeah. So I'm not perplexed at all that you're not writing this down, because you really don't need to, because you understand this. That sentiment maybe is not shared with everyone else, and that's your choice. We're in high school now, right? You probably get tired of hearing that. So should we treat you like young men and women, or should we just say, now kids, boys, girls? Is that annoying? I would think so. But regardless, let's go ahead and move forward. Okay. Antimony. What is the symbol for antimony? Okay. So, Sb. What's the formula for the sulfate ion? Okay. So, notice what's the difference besides the charge of whatever it is negatively. What's the correct term for the difference of this type of ion as opposed to that one? Chloride is a monoatomic ion, where sulfate is a polyatomic ion. Okay, so formula for sulfate is what? Okay, the charge of the sulfate ion is -2. You know what the charge of antimony is? You don't need to look at the periodic table. Yeah. The reason you don't need to look at the periodic table is we've already told you. Yeah. It's this Roman numeral right here. Okay. These charges, do they add up to 0? No. So the next thing you do is find what? Least common multiple between 2 and 3 is what? Okay? So 6 divided by 2. Okay? Okay? And then 6 divided by 3. Okay. Left outside. How are we doing so far? We're following along. We're on the bus. Okay? Middle. Okay? Left middle. Right outside. Okay? Right middle. Okay? So for some of you who are doing this or shaking your head no, you've got time. If you just want to sit there and say, I don't get it, not come in before or after school, ask for extra help, what else can we as a staff do to help you? And I don't have an answer for that. It's one of the things you're going to have to be able to work through. And I think, did we have this conversation before? Like, for instance, we'll just pick on you two back there. During the course of a basketball game, do you ever have official blew their whistle, called a foul on you, in the back of your mind said, I didn't even touch the person? Has that ever happened? So, should that be the case, you can't let that, let's say, what's the right word I'm looking for? Determine how you're going to react with the rest of the game. If you just want to hang your head, and not that you would, and I'm not saying that you did, but you don't want to hang your head and pout about it because, oh my gosh, I didn't do anything wrong, they gave me a foul anyway. It's going to happen, okay? So it's one of those things that then as a team, you have to find a way to overcome something like that. So, and bad calls are one of the things that results with some of these outcomes. Anyway, moving forward, okay? So with this, what is the mass of a sulfur atom? Okay? So how many times would you write it like this or take it times by? Okay, so let's just go ahead and take it times 3. So why are we doing that? Yes, you need to distribute that 3 through there. So 32.06 times 3 gives you 96.18. Okay, so what's the mass of an oxygen atom? Okay, so there's 4 of them inside the parenthesis. Okay, and there's a 3 on the outside. We just said you had to distribute it. 3 times 1, that's where the 3 count comes from. 3 times 4 gives you 12 then. So distributing that, taking 16 times 12 gives you 192. Okay, and then 1 antimony atom. 92? 121. We'll just say 76. I don't know what you said. Okay, we're going to take that times what? We're going to take it times 2 because there's 2 of them. Okay, so 121.76 times 2. Okay, so that's 243. And we're going to add 192. Oops. 531. Okay. So naming compounds. So yesterday we worked on what 2 aspects that you've learned. A linear depiction of electrons is called what? transfiguration, no. It's close. We haven't quite done that yet. We did Bohr models and an electron configuration. Transfiguration, I suppose you could say the same thing. Okay? But electron configurations and Bohr models we worked on yesterday. That was one of the first things we did way back in January. Long time ago. Okay? So then we started working on naming compounds and adding together atomic masses. Okay? Now, this was used not only with the organic section, because COOH is designating what type of organic family. It's an acid. Okay? So we could also do an electron dot diagram for that. So how do we know which element to put in the middle? What does anyone remember how we approached that? It's either carbon or what's its next door neighbor? Nitrogen. And if it's not either one of those, it's a metal if that's present. Unlike these over here, okay? These are all acids. We can do those as examples as well. Okay? So, you correctly said carbon goes in the middle. Okay? So, what column is carbon in? Okay? So, what we do is perhaps put these 4 dots around. Okay? So now, let's go ahead and put an oxygen atom. So where do you want to try to put a bond on there? Left or right? Okay? So we could say that oxygen's in which column? Okay? All right, well, that took care of one oxygen. We're not done yet, but where do you want the other oxygen? Okay? Who wants it on the bottom? Who wants to finish this? Okay, you want to finish that? No? You want to finish it? Sure, right? Why not? Then you're illustrating whether you do or don't understand this, because since we're not writing it down, we must be understanding this. Now, wouldn't that be a logical conclusion on this end of the table? Since a lot of you don't write this down, we must understand this. What other conclusion should we come up with? Nothing? Just what conclusion should we come at? Because I see 1, 2, I can't tell back there, 3, 4 probably, 5, 6, and maybe 7. You're writing this stuff down, right? No? Oh, okay. Okay. So where do you want this oxygen then? Okay. Now, the reason I'm not asking how many electrons it gets, because if this one had 6, well then common sense should tell us that this one would get 6. Okay, and that leaves what's left over. Okay, well, how many dots and X's are around that carbon? There's 6. Well, we don't know that yet. You do, but we don't. We're just saying we don't know that yet. How many dots and X's are around here? What about this one? Okay. What about this? Well, we got that hydrogen. Okay. So if you arrived at this conclusion, this tells you this is not correct. Agreed? Okay. Well, How would we go about fixing that? We can certainly put a double bond on there. Okay? So when you arrive at these and looking at it, if this is not right, the best thing that you can do is just start all over. Don't try to look at this and analyze, well, if I move this electron here, this one there, it'll all work out. Don't do that. I'm not passing that wisdom off that that's what I had learned or that's what I came up with. No. I had a math professor over at Dakota State would say the same thing. If this doesn't make any sense, the best thing to do is erase it or just start all over. And that, I do believe, there's something to be said for that. So you had correctly said, if we put a double bond on there, let's go ahead and do that to an oxygen. Why not double bond a hydrogen on there? Because it can't do it. It doesn't have enough electrons for that. Okay? So, and that's how we make a double bond. There's 6 X's. Okay? And then it's got its 2 dots for the carbon, the 6 for the oxygen. But how many dots are left for this carbon? There's still 2 left. We're not going to split them up because you can't. And this is why. Because if you put a dot here, granted, you can put a hydrogen on there, and then there's a dot here for that 4th one for that carbon, but you're still going to be in that same boat. This oxygen here is how many short? 1, because there's only 7 around here. Okay? So, to fix that then, let's go ahead and put 1 there. Okay? Still 1 short. Okay. Oops. Seems to be a hydrogen. Something's not right here. I'm going to have to come back to that. Okay. We'll discuss that tomorrow. I just want to make sure I'm explaining that correctly. Okay. So, moving on to this. Ammonium. What is that? Formula for that. The only positive polyatomic ion. NH4 plus 1. Nitrate is what? N with a what charge? So those add up to 0, so do you need to change anything? No. No, you do not. Okay? So, as we look at this, probably one of the more common mistakes that people will make is they'll do 1 nitrogen instead of 2 because it's in 2 separate spots. That's something that some people just aren't used to seeing. So, one oxygen atom is 16 times 3 is 48. Okay, 2 nitrogens, one of them is 14. You double that, 28.02. And then finally, 4 hydrogens at 1.01 each, 4.04. Oops. And then, let's see here, 16, 22. Okay. Adding together atomic masses. All right. Are we good with that? Left outside, right middle, middle, right outside, left middle. All right. So we've got two concepts left to review. Well, two really broad concepts, because that was the chapters we went over. One of them was what? About reactions. Balancing chemical reactions. And the other one we just finished, which is what? Organic chemistry. Okay. So, should you be having problems with this, please get in, talk to myself. We can't make you come in and talk to us. All right. So we will catch up to you next time.